Hello everyone, and welcome back to the second video of this series, in which I'm teaching how to model an end plate steel connection, such as this one that you're seeing here. And we are pre-processing in any software named ANSA. We are going to solve in Abaqus, and we are going to post-process the results in MetaPost. In the first video, I explained in details about this whole procedure that we are going to follow. So, here I have the working folder with my .ansa file. In the previous video, we have created this file. And I'm going to open up a new ANSA section. I'm going to use ANSA layout and click on OK here. And now that this is opened, let's close the release highlights, and there are two ways we can open this file. We can drag these with the left mouse button like this and position this file here, or we can copy the path to this folder, Ctrl+C, File, Open, Ctrl+V here, Enter, and then here we are in the working folder. We can select this file and click on Open. So let's do here an overview about what we have created so far in the previous video. So in the database, we have these items. If you're not able to see the database, go to lists, and then you should have database activated. Looks like we have this shortcut here as well to activate it, F12. Okay. And then you will be able to see this database. Depending on the ANSA version that you use, the structure might look a little different. In here you have some groups. So for example, this first group is FE structure. This second group is geometry. So we have geometry entities here. And this one is ANSA auxiliaries. Maybe in your ANSA version, you don't have these groups. I remember that in a previous ANSA version, these groups didn't exist. Just one second. Okay, so let's go one by one here, because it's really important to always keep a complete control over what we have in this database. So first of all, we have these item properties. We can maximize it, and inside, let me increase the size of this column. So you see that in here we have a table, right? We have a table with 1, 2, 3, 4 columns. So in this first item, we have 2 shell sections. If I double click on shell section, it's going to show up a list of the shell sections that we have created. So in the previous video, we had created this property, beam web. So this is considered a shell section, because if we double click on it, you see that this card opens, and then we have this title for this card, shell section element type. Okay, so for Abaqus, this is considered a shell section, and this is going to assign some properties to the shell elements that we're going to create on the face that we had assigned this shell section. In this case, it's the face that is painted in green, the beam web. And then we have the beam flange shell section, which is a property. Okay, one thing that is important for you to understand is that in ANSA we label as PID. Well, the abbreviation of PID, which is what you see here, PID, is property ID. So for example, here we have this property, which is a shell section property with ID equals 1. So the PID is 1. Okay, and then we also use this name MID for material ID. So this is something that you're going to get used over time. Okay, PID and MID. I'm going to use these words a lot. So we have these 2 properties. Let's go to materials. We have only one material. This one is still for thickness less than 16 millimeters. We have created only this material. The ID is 1. So this means that the MID is 1. Let's go to the geometry entities. We have 5 faces, double click. So for example, this is one face, this is another face, the third face, fourth and fifth face. Now let's go to the next item. Here we have cons. Cons is the abbreviation of curves on surface. So for example, this red one is a curve that is part of this surface here, this face here. So for this face, we have this cone, and this cone. And we also have this other cone here. But you see that this cone is red and this cone is cyan. I have explained in the previous video that red means that this cone is connected to only one face. And cyan means that this cone is connected to 3 or more faces. In this case, this cone is connected to this face, and this face. Okay, you're gonna see that we have also the double cone, which is connected to 2 faces, but we don't have it yet here. We will shortly have it. Let's go to the next item. We have hot point. This is something new. We have 12 hot points. I'm going to double click here and I'm going to zoom out, create a box selection with the left mouse button. And then you see that we have these points that were created. In this case, we have 1 point at each corner of a rectangular face. For now, let's just understand that these are points on surfaces. You're going to see that these points are important when we are dealing more with mesh. Okay, maybe in this tutorial, the mesh is going to be so simple that we will not even need to work too much with the hot points. Okay, but anyways, over time you're going to understand more and more about hot points. For now, let's think that these are just these points that if we zoom in, they are these pink points. And by the way, you should be in the classic topo module. So in here, click on this drop down list and select classic topo. Because don't do what I'm going to do now. If I go to the mesh module, you're going to see that the visualization of some things are going to be different. The hot points are going to be this white dot, and then we're going to have these other pink points, and I'm going to talk about it later. Okay, so let's go to the classic topo module, and then in here we have the hot points as these pink points. Okay, all right, let's go to curves. Curves, we have created these 3 curves in the beginning of the tutorial. And we use it to extrude the faces. You see that there is a difference between curves and cones. These curves are not associated with the surface. These are isolated entities. Now, cones are associated with the faces or surfaces. Now, we have these 2 points that we have created in the beginning, and then we have the ANSA part. If we double click here, we have these 2 ANSA parts that we have created. ANSA auxiliaries that we have included the curves and points, and beam that we have included the faces of the beam. Okay, by the way, it's very important to always keep complete control over the parts so that by the time we finish creating this model, it's not going to be messed up. Another way to access the parts created is by clicking here in Model Browser. Or we can access Model Browser in lists in here. Okay, so click in Model Browser. I have the Model Browser opened as a new tab here. Depending on your ANSA configuration, sometimes it opens as a tab here, or if I left click and hold like this is going to become this window. Okay, I prefer to look at it like this. And then you see that in here you have the parts that we have created. We even have this image that shows up. So this has the cones and points. I can go to content and check what we have here. So you see we have the 3 curves and 2 points. And then in beam, we have this image showing what we have. And then in content, we have 5 faces We have one material, two properties, and the ANSA part itself. Okay, so it's very important to keep control over that, because when we are dealing with complex models, it's going to make a huge difference to have the model browser organized. But sometimes, if I'm going to deal with a simple model, I don't even look at the model browser, okay? If I know that the model is not going to be complex. But in this case, even this model not being so complex, let's learn how to deal with the model browser. And then the last item is related to the working planes that we have. So remember that the working planes were created automatically when we created this model. We have the XY, YZ, and ZX plane. Okay. All right. So the next thing that I wanted to do is to create the end plate, which is a part that is easy to draw. Here we have the dimensions that we should use to create the end plate, these ones. So we should create a rectangular face with the holes for the bolts. So let's create it. You see, we have this side where we have the curves. I want to create the end plate on the opposite side. So for you to be sure that you're creating on the same side, look at the coordinate system that we have here, and we have the positive sense of the x-axis. I'm going to create this face here on the positive sense of the x-axis. Okay, let's rotate the view holding Control and the left mouse button. And then there are many ways to create this face. Again, ANSA is not really the best software to create CAD, to create geometry. It's a good software to modify CAD. I'm just showing to you how to do this because you're going to end up learning about important things, such as creating points, creating faces, and things like that that are important, even if you're not going to create the geometry from scratch. Okay, so let me deactivate my camera. To create the rectangular face, I want to create 4 points to use as a basis. So let's create a new point. So I am in the classic topo module, and then I have the points group, new. Oh, actually, I'm going to use the relative tool, so I can create a point relative to another entity. So I want to create a point relative to these hot point that we have here. So click here, middle mouse button, and then I want to create it in the positive z direction. So you see we have dx, dy, dz. I need to define a unit vector to define the direction. So I'm going to define the vector 0, 0, 1. So this is a unit vector in the z direction. And then the distance is, let's look at this image. The distance, I want to create a point that is here, right? And what I have is the middle surface. Looks like we have a 50 plus 50 from this upper surface to this point. So it is 100, but what I actually need to consider there is 100 plus half the thickness of this flange. The thickness of the flange is 12, so we should have 6. So it's going to be 106 mm. Type 106 here and click on OK. And there we have the point created. Do the same thing here. So I have the tool activated yet. Now I want to create a relative point related to this one. Middle mouse button. And then instead of setting up manually the parameters here, we can left click on this point, and then the number 1 is going to appear there as the first point selected, and left click on this one, and then the number 2 is going to appear there as the second point selected. And then the software is going to calculate the direction from point 1 to point 2 and the distance, and it's going to set up the parameters here. Click on OK. Now you see that it has created this point, distanced by 106 millimeters and in the positive z direction. We can check it by using the measure tool. Again, if you don't find any tool that I'm using, always search here in the search bar. Measure, and then we have utilities, measure. Left click here, and then it shows where I can find the tool. And it also activates the tool. And then I'm going to measure from, I have the dynamic selection mode, measure from here to here. And then I have 106. If I store, it's going to show in here the distance and the unit vector of this distance. So you see, it's not actually a unit vector here, it just shows the components. So in the x, y, and components are equal to 0, and the z component is 106. Okay, now you see that we have this measure here. I don't want to see it. You see that we have this new item in the database, measurement, double click on it. We can deactivate the visibility by clicking here, or we can simply delete this measure, right click and delete, okay, because it's not really important to keep it. Now let's use the relative tool again. Now we can select this point and this hot point at the same time, middle mouse button, and then we can select this as the first one and this as the second, and okay. And now it creates both points in the negative z direction because I selected first this one and then this one, and there is a distance here of 106 mm. Okay. All right. Now the next step is to create curves connecting these points. So we are going to use the in the classic topo module, search for curves group and then create here. If you don't find the create tool, you can expand more tools by clicking here, and then we are going to have other tools. Okay, so create, and then I want to create a straight line, and then from this point to this point, and then to this point, and then to this point, and then to this point. Now we need to click the middle mouse button to confirm the creation of these lines, because if you don't do that, it's not going to create. All right, now we can close these, and now we're going to learn about a new tool, which is to create a new face. Inside the faces group, we have the new option, left click, and then we have these 4 algorithms to be used to create a face. In this case, since it's a very simple face, we can use any of these 3 algorithms. This first one is just when we have an existing surface. It's not applicable in this situation. When we have a situation that this is applicable, I'm going to teach what it means. By the way, you know that I have the I have the ANSA meshing course in my blog, Learn FEA. In that course, I teach only about meshing, and then I teach in details about many of these tools. Okay. All right. So I'm going to use, for example, the planar algorithm because I'm going to create a planar face. So this is a good algorithm. But to be honest, these other 2 algorithms would work as well. So select. So you see that when we activate this tool, it orients what we should do. So we should select cons or curve. In this case, I want to select this curve, this one, and this one. I'm using the left mouse button. There is no need to hold the control key. And by the way, you see that on this side of the screen, we have some configurations. So for part, it's going to use existing, and for property, it's going to use existing. Instead, I want to select here, ask always for part and ask always for property, so that it's going to ask what property and part we want to assign this new entity. Because I want to create a new property and part. Middle mouse button. Now it's asking what part I want to assign this face. I'm going to create a new part, left click and hold until you see these options, and then select this option, and then left click to rename, and let's rename it as end plate. Now double click on this new part, and then we have this new face assigned to this new part. Now we should create a new property or PID for the flange. If we go back to the article, we have that the end plate thickness is equal to 20 millimeters for the SC2. Okay. And also, there is one thing related to material that we should be careful. He says here that those plates, actually here, plates thicker than 16 millimeters has this yield strength and modulus of elasticity. So we need to create a new material for this, because the plates that we have here are with thickness less than 16. Okay. Anyways, for this, let's create a new property, new, and then it's going to be a shell section. And then the shell section card opens. We can give it a name, end plate. And then we have the property ID. This is the third property that we are creating, so it assigns the ID 3 for this one. We have the thickness, type 20. The type is going to be S underscore. This means that if it's a triangle, it's S3. If it's a quadrilateral, it's S4. And then material, we have this material with ID 2. Looks like it created one new material automatically. If I use the question mark when I select this and use question mark, I'm going to have a list of materials available. We have the first material that we have created, and there is this new one that the software is creating automatically. We can select this new one with ID 2, double click on it, but I want to modify this material because I need to assign the properties. To modify it, I can simply select here and press F2. When I press F2, I open the card of the material. I can change the name of this material. So the name is going to be steel thicker than 16 mm. And then in here, the Poisson's ratio should be 0.3. The modulus of elasticity should be 204, and 227 MPa. Remember that in ANSA, just like in Abaqus, we should choose a set of units that are compatible. So again, I guess I have mentioned this before, but let's repeat. Stress, I'm using Newton per square millimeter, which is the same thing as megapascal. Length millimeter, and force Newton, and mass tons. The density could be this one. This is a standard density for steel. We can use it. There's nothing about density here. What else? Yep, that's all we are going to define now. And later, we are going to define the plastic properties here. But let's not do this now, because I want to explain more in details about the plastic properties. So for now, click on OK. And now we have this material assigned to the end plate with ID 2 thickness, and that's all right. Let's click on OK. Now we have this new property. So you see that in ANSA, many times we have many windows opened at the same time. Previously, when I started using it many years ago, I got really confused. But you're going to end up understanding how it works. You know, at first you're going to get a little confused, but eventually you're going to get used to it. We have this new property and plate with ID 3. So the PID is 3. Double click on it. And then it asks if we want to accept the surface created. We can click on OK. And then we have the surface here created. Okay. All right. Now we need to create the holes. So you see that usually when you're creating a plate with holes like this in a CAD software, you define a sketch and you draw the rectangle with the circles, and then you extrude, for example. So you do this at one shot, but in here we need to do this part by part. So again, this is not a software appropriated to creating CAD. So let's see how we are going to create the holes. And to create the holes, we need to draw circles here as curves, and then we need to project these curves on this face. It's actually easy. To create these circles, we need to create some points to define the center of the circle. And we have this information on this drawing here. Okay. So we need to get from this corner and create a point that has a vertical distance of 50 and a horizontal distance of 46. Okay, let's actually look at this corner. And then we have this vertical distance and horizontal distance. So to create this point, I'm going to use again in the classic topo module, the relative tool. I want to create a relative point from this corner, left click here, middle mouse button, and I want to go in this direction that goes from this point to this point. To define this direction, I can left click on this point and then on this point. But you see that it has defined the direction as -1, which makes sense because -1 is the negative y direction. But the distance is 200. I don't want I need to modify this distance, and the horizontal distance is 46. So define 46 here and click on OK. Now we have this point here, but now I need to displace this point in the downward direction. So I want to use a tool here in the there is this transform tool here. If you're not able to see it, click here to see more options, and then transform, move, and then I want to select entities because a point is a kind of entity. Select, zoom in and select this point, middle mouse button, and then you see I want to move and not copy. I want to translate in the negative z direction, -1 here, and the distance is 50. 50, and then click on plus to go in the direction that we defined. If we click on minus, it goes in the opposite direction that we defined. Here we have the point. Click on finish, and now we have the center of our first circle, right? Now I want to create the center of this circle that is going to be positioned here. So the distance is 50 plus 62. So it's going to be 112. So to do this, now we're going to use the transform tool, copy instead of move, and then select this point, middle mouse button, and then you see that now we have copy here. I want to move in the negative z direction, so -1 here, and 112, right? 50 plus 62, 112 plus, and then it asks if we want to create this point on the same PID. The point doesn't have a PID, so we can just select no offset here, doesn't matter. And part could be in the same part, and set could be in the same set. There is no set related to this point. I'm going to explain what is a set later. Click on OK, and now we have this point here. Now click on finish. Now the next point is distance by 176. So you see that I have the copy function activated yet. You can see this in here where my mouse is positioned. We have copy activated and we need to select any entity. So let's select this point, middle mouse button, negative Z and 176. Yeah, plus, okay, finish. Now the next one is distanced. Here we have 112 again. So select this point, middle mouse button, negative Z, 112 plus, okay, finish. Now I need to create the points on the other side, and the distance is 54 plus 54, 108. So select this point, this one, and this one, middle mouse button, and I want to go in the negative y direction. Look at the coordinate system here, and the distance is 100. Oh, how much it was? 108. 108 plus, okay, finish. Now we have the center of these circles. Let's create the circles itself. If we look at this table, you're going to see that the diameter of the bolt is 20 millimeters. Obviously, that usually we need to create a hole with a diameter a little larger, like maybe 2 millimeters larger or something like that. But in here, let's simply create this hole with the diameter of the bolt. Actually, let's not do this because we're going to create the bolts as solid entities later, so it's not going to be really a good idea to have 20 millimeters. So let's create it with 22 millimeters then. Okay. To create a circle, we are going to go in the classic topo module, and in curves, create, and then we have the circles option. But if I simply try to create a circle centered, for example, here, the plane that the circle is going to be created is going to be arbitrary. So we need to define a plane. To do this, click on 2D mode. And then right now the plane selected is this one. It's not correct. So we need to select a new plane. So click in select plane, and then position the mouse here, and then you see that it's going to recognize a plane that is parallel to this plate. Left click, and then it's going to ask what part we want to assign this new plane. Double click on auxiliary entities, and now we can activate the circle a tool. We have some options here: center radius, diameter, and 3-point. Select center radius, and then left click here. And then one thing that is important is you see that I'm moving my mouse in the horizontal direction, and there is this snap here with this dashed line, right? I want to create the circle like this because it's going to create a hot point where my mouse is positioned, and it's going to force a node of the mesh to be positioned there. So it's important to position well this point. So with the mouse along this dashed line, if I want to define a value for the radius there, I need to press space. Now I can define a value. In here, I want the diameter to be 22, so the radius is 11, and then press enter. Now we have the circle created, and then you see that it creates one hot point here and one hot point here. And in this case, the hot point is going to force the mesh to position a node in this region. Now let's do the same thing here. Left click, position the mouse along this dashed line, space 11. And we can create these circles everywhere. In here you see that it recognized an align there, and then I can simply left click and it's going to be a circle with 11 mm radius. And here it's not recognizing. Let me go on to this side. No, it's not recognizing. So space 11, enter. Okay, in here it's recognizing. In here as well. Okay. Now I can close the create curves tool. And the thing that is very important to understand here is that what we have created are curves. So double click on curves, and then you see that in here we have curves, right? These curves are not associated with the face yet. We need to transform it into cons. To do this, we're going to use the project tool in the cons group. Project, and then we should select these cons. I'm going to create a box selection like this for each. Let's not select these cons that was used to create the face. Okay, so be careful. Looks like I'm selecting something behind here. So I'm going to deselect it later. So in here, you see that I selected these, right? I'm going to deselect with the left mouse button. Okay. Now, after selecting these, middle mouse button, and then it says select face that you want to project these curves. I'm going to select this face here, middle mouse button. And now it has created the cons, but we're not able to see it because the curves are on top of it. So let's deactivate the visibility of curves by unchecking this box in the database. And in my ANSA, I have the visibility of double cons deactivated. Let me explain to you about the visibility tools here. You see that we have these yellow tools, right? This is related to visibility of some specific entities. So this first one is for visibility of macros. Macros is another name for faces, or surfaces. If I deactivate, I'm not able to see the faces anymore. But since the cons or curves on surfaces are attached to these faces, I'm not able to see the cons as well. See? Now this one here is for cross hatches. If we activate it, we're able to see these cross hatches on the faces. I don't really use it so much. This facilitates the selection of some faces sometimes, but I don't really use it so much. So deactivate cross hatches. And then the next one is perimeter points. If we click here on this drop down list, we have hot points, spots, and perimeter grids. Hot points are these pink points that we have here, right? So if I go here and deactivate hot points, I'm not able to see these pink points anymore. So activate it. Well, spots is something that I don't really use. But if we end up using spots, then I'm going to explain what is it. Okay, we don't have any spots here. Perimeter grids, I'm going to explain what are perimeter grids when we create the mesh, because this is related to mesh. Okay, we can let it activated. Now the next one is perimeters. Again, this is something that I'm going to explain in the mesh. You can let it activated. And then here we have single cons, which are the red ones. If I deactivate, I cannot see the red cons anymore. Let's activate it. We have this last one, which is triple con, which are the cyan cons. If I deactivate, I cannot see the cyan cons anymore. Activate it. Now we have this one that is not activated in my case, double cons. I'm going to activate it, and I'm going to let activated active and joined cons. When I do this, you see that I can see these yellow cons. These yellow cons means that it is a curve on surface connected to two faces exactly. So for example, we have this con here, right? It's connected to this face and the outer face. So two faces. We have this con here, for example, this one, the same thing. So we have here yellow cons. These are double cons. Okay, So single cones are red, yellow cones, double cones are yellow, and triple cones are cyan. All right. So the thing is, I want to actually delete this face because I want to have a hole here. To do this, I can simply, there is two ways to do this. I can go to faces and delete, and then select this face. And then since I selected something here that has two faces around in a near region, it's asking, it's this face highlighted or this one that you want to delete? It's this one here. So select it and delete. Now this one I want to keep. Another way to delete a face is by using the delete function here. Zoom in, select this, and then zoom out, and then zoom in, select this, and anyway, select all these faces to open the hole. Mise au mouse button and click on OK. All right. Now we have the end plate modeled. You see that even though it's not so practical, it doesn't really take so long to do this. Because, well, I'm explaining how to do this, but if I wasn't explaining, I would create this whole geometry in like 3 minutes. All right. There is another thing that we need to do here. Notice that the end plate is not connected to the beam yet. Because you see that these cones that we have here are all red cones, which means that they are connected to these faces here of the beam, but they are not connected to the end plate. Okay, well, in reality, we would have a weld between the end plate and the beam, right? We can we probably have a weld here all around. We actually have it. It's defined here in this text somewhere. Here we have here we have this information of the weld. So you see that in this drawing we have a full penetration weld on the flanges of this beam. But in here we can assume that we also have these welds in the web of the beam. There are many ways to represent a weld in a FE model. In this case, the best way is to represent it with a continuity in the mesh. So basically, the nodes that are going to be positioned on this cone are going to be part of the elements of this face and of this face. So we're going to create a continuous mesh. I have this in here. You see? Between the flange of the beam and the plate, I have a continuous mesh. So for example, this node is part of these elements, this element, this element, this one, and also this one and this one. Okay. This is one of the most practical means to represent welds, and it's suitable for this condition. Now, obviously, that there are other ways. In this tutorial, we're not going to see these other ways. Maybe in future tutorials, we're going to see about it. Okay, there are even tools related to how we can create these connections in a more automated manner here. Maybe we're going to explore these one day. Okay, depending on the problem that we are solving. So the thing is, how do we connect then the beam to the plate so that the mesh is going to be continuous? I need to project these red cones of the beam on the plate. And not only that, I need to project it and connect to this plate. Okay? There is a difference. I'm going to show why this is different. So let's go to the classic tuple module. And again, I'm going to use the project tool inside the cons group. And then in here, we have the options list. You see that we have this option here, paste activated, right? If I have this deactivated, and if I select, you see that when I have this tool activated, I have this orientation, select cons that I want to project. Select this one, this one, this one, this one, and this one. Okay, and then a middle mouse button, and then select face, this one, middle mouse button. Now you see this worked because we have the cons projected here, but these are yellow cons, which means that, for example, this cone, this yellow cone, is part of only two faces, this face and this face. But that's not what I really want. I want this cone to be part of this face, and this face. So I would have to have a cyan cone. This happened because we projected those red cones that are yet here, but we have the yellow cone on top of it. If I isolate these, I'm going to be able to see the red cones here. I'm going to teach you how to control the visibility of entities shortly, okay? It's related to these tools here. So anyways, this is not connected yet. To connect it, we should have used the project tool with the paste option activated. Or, since we have already used the project tool, there is another manner. We have the paste tool here for cons. We can zoom in, actually select it, zoom in and select this cone. And I want to paste it with this other cone, this red cone, which is on top of it. But if I select again, the software is going to understand that I'm selecting the other cone that is positioned here. And middle mouse button, and now we have it as a cyan cone. We can do the same thing here, select these, and then select again to select the one that is on top of it, middle mouse button, and then it's cyan. There is another way that is more automated to do this, which is to use the tuple tool inside faces group. Select the tuple tool, and then in here, if we create a box selection like this, and it's going to select all these cons, the software is going to recognize the cons that are very near to each other, and it's going to paste them together automatically. And the distance that these cons should be is defined by the tolerance that we have here. So in here I have middle tolerance, we have these other options. If I select, for example, extra fine, we should have the cons very, very near so that the software is going to paste them together. We can try it with middle mouse button, and then you see that it has pasted all these cons together that were near to each other, but it didn't paste, for example, this con with this con because it's not near to each other. It's not parallel because, for example, this point is very, anyways, it's not near to each other. Okay, or we can Control Z, Control Z, Control Z, and Control Z again. So we Control Z until the project tool. We can use the project tool again, activate paste, and select these cons, middle mouse button, and select this face, middle mouse button, and then you see that it projects and pastes the cons. Okay. So you see that when we create these entities, we end up learning a lot about very important tools that are used even when we already receive the CAD ready, because we always have to work on the CAD to fix some issues. And we use these tools that you're seeing here. All right, before we end this video, I wanted to finish everything related that is connected to this beam. So I want to finish the stiffeners, these triangles that are pretty easy, and that's it. That's all I had connected to this beam. And then in the next one, we can model the column. And then we're going to be finished with the CAD. To generate the mesh is going to be pretty easy, and then to generate these connections, it's not going to be so, it's going to be easy as well. So I guess I will be finished with these in maybe 4 videos in total. So we are in the second out of 4. I'm not sure yet, actually. Maybe we will need more. So let's create the triangle, the stiffener. We have this information here that we're going to use. So it goes from this edge, and we have this distance here. Okay. So first of all, I need to create a triangular face, and for that I need to have 3 points. So let's create these points. The first one is going to be, I'm going to use the relative tool. Let me think here, actually. Yeah, relative tool. And then I want to create from this hot point, mesomos button, and then use these 2 points here, mesomos button. Now we're going to have this point here. Now I want to create a relative point from this hot point, mesomos button. And now I want to go in this direction from this point to this point. So I'm going to move along this CN line, but the distance here is 100, not 1200. Click on OK, and now we have this point. Now we can create the curves. So create line, and then instead of 2D mode, deactivate 2D mode, select this point, then this one, then this one, then this one. Mesomos button to confirm, and then select auxiliary entities as the part. And then I created the curve, but it's not visible. So activate the visibility of curves here by checking this box. And then close this, and let's create a new face, new planar, select. Oh, just so we don't mess up with the selection, deactivate, let me see here, macros, the visibility of macros, and then select these, and these, mesomos button. And now let's create a new part for this one. And by the way, for this to show up to you, let me close this and also this and cancel. In the options list, when we have the new face activated, select Ask Always and Ask Always here, and then mesomos button, and then create a new part. The name is going to be end plate rib stiffener. So let's put it here as end plate rib stiffener. I guess it has 2 ends as well. Let's see, no, it has 2 F's. This is a complex word. Oh, I need to modify the name. I select it with no purpose. So now we need to select a property to assign this. We have this property that was created before when I created this face. Let's create a new property here, and I need to delete this property later. New shell, and then it's going to be end plate rib stiffener. FFE stiffener. Now we need to assign a material. Let's see the thickness of this. I have this information in the text somewhere here. Geometric details of connections, maybe here. Yeah, in here. The thickness of the column paniol zone stiffener and the end plate rib stiffener is 12 and 10. So the end plate stiffener is 10 millimeter. So for 10 millimeter, let's use the question mark to see the list of materials, and I want to select this material here, steel for a thickness less than 16. And then the thickness is 10. The type is S, and the property ID is 5. Let's click on OK. Double click on this. Maybe in your case you don't have this shell section created, the fourth one. So this new one that you're creating has the ID equals 4. It doesn't, the ID doesn't really matter. Double click here, click on OK. And now let's activate the visibility of macros, and there we have the stiffener. All right, now let's go to property list. And then I have this new property created. You see that the lamp is like this lamp is like this. If we right click on this and click on reference, it shows this message here, shell section ID 4 is not used. So this is not being used. I'm going to right click and delete. We can delete included entities. There is no included entities. And then this property here that I've just created has the ID 5. Let's just double click and change the ID to 4 just for organizational purposes. Click on OK. And now we have it organized. Close this. Let's go to material list. And then I have this material created. I don't know why it created automatically. At some point, I'm not using it. Right click and reference. It's saying it's not used. Right click and delete, just to have it all organized. Now, deactivate the visibility of curve so that we can see the cons. And you see that this triangle has only red cons. We need to connect this triangle to the beam and to the end plate, because we're going to have weld here as well, and I'm going to model the weld as a mesh that is continuous. All right, first of all, I need to project this cone on this face and paste it. So let's use the project tool, and then in here, activate paste, and then select this cone, middle mouse button, and this face, middle mouse button. Now it's connected. It is a cyan cone. Okay, now the same thing here. Actually, in here we should simply paste. So let's use the paste tool, paste cones, and then select this cyan cone and this red cone. You see that I've just double clicked on the same position and the software recognized the two cones. Middle mouse button, and now it's connected. Okay, in this case, we have this cone here that is connected to this face, this face, this face, and this face. In this case, it's connected to 4 faces, but it's a cyan cone because cyan cone is for 3 faces or more. Now we should do the same thing below here. I'm going to do this faster because now you know how to do this. So let's start creating a relative point. Oh, my camera, I guess it's not in front of it, right? I don't know. Again, I'm going to deactivate my camera. I'm using the relative tool here to create a new point. Select this point, middle mouse button from here to here. Middle mouse button. Now we have it created here. Now again, select this one, middle mouse button, and then I want to create. We can use this reference here from here to here. Middle mouse button, and there we have it. Now I want to create curve, line, deactivate 2D mode, and then create this triangle here. Middle mouse button, assign to this part, and then activate visibility of curves, new, planar, select this, deactivate macros visibility, select this and this, middle mouse button, and then we can put it in this part here, end plate rig. I need to rename this. Let's rename this. It's rib. Oh, sorry, rib stiffener. Now select this one and select this property that we created. Double click and then click on OK. activate visibility of macros, deactivate visibility of curves. And here we have the triangle. Let's use the project tool. Here, middle mouse button to this face. Middle mouse button, you should have paste activated. Now I want to use the paste tool and then paste these to this. I just clicked twice in the same position, middle mouse button, and we are ready. Okay. So again, this is something that when you get used to it, you would do this in like 5 minutes. And another thing is that you're going to notice that we use just a few tools that we have available here in ANSA. ANSA has too many tools available because imagine that this is a software that is used to create modules for many kinds of like CFD modules, FEA modules, and we have many solvers. So it has many tools, but we end up using just a few important tools. You're going to notice that. All right, I'm going to end this video now because I guess it's pretty long already. I'm not sure. And in the next one, we are going to create the column and etc. I hope you are liking it and see you in the next video.